All right, you guys, so the second piece of Module 15, Part 2, we are dealing with hypothesis testing using the mean. So everything we've gone through over the past 3 modules, we've done with the proportion and we've done with the mean. And so for this hypothesis testing, we are going to use the t-test. So we're going to use, even though most of these are going to be normally distributed, we are not going to use the normal curve. If you remember from the notes from 15 part 2a, instead of using the normal curve, we're going to use the t-curve, which is shorter and, well, that looks terrible, but the t-curve, which is shorter and more spread out, right? More room for error with the t-curve. So, of course, our wonderful head of this class has given us some tables and rejection rules. So please read through that, and you will see as we move through doing the examples, we might go back up and use those. Okay. So, and here are the steps, right? State the hypotheses. We've just been working on this. State the rejection rule, calculate the t-data. And here, you can calculate the t-data here. You can also calculate the t-data here. Quite honestly, I feel like using the equation is going to be faster. But take a look at these steps if you want to use your calculator instead, and state the conclusion and the interpretation. So on the notes, the examples are written out for you. I'll just go through them with you here. Let's see, let's make this a little bit bigger. All right. We are interested in testing at a significance of 0.05. So this is important to remember what type of hypothesis testing we're doing, and we're doing the p-value. So we only need to worry about this at the very end. Okay, we don't need to go back in and find that significant number. Whether the mean age at onset of anorexia nervosa in young women has been decreasing. Assume that the previous mean age at onset was 15 years old. So there's our null hypothesis right there, you guys. That mu is 15. Data were gathered for this study from 20 young women who admitted to Toronto Hospital for Sick Children. Assuming that the sample distribution is normal, okay, so that's important. We are assuming the sample distribution is normal. And this is going to help us. So even though it's normal, I said before, we use the t-table when something's not normal. We can still use it even when something is normal. It's okay. With the sample mean age of 14.251 years and a sample standard deviation of 1.512 years. And we want to go back here and highlight one more thing. This study, we were trying to figure out whether the mean onset age of anorexia in young women has been decreasing. Oh, look, they already like highlighted that for us. Okay, so that becomes our alternate hypothesis. So that shouldn't be H sub 0, that should be H sub A. Okay, so we're going to state the rejection rule. We are going to reject H sub 0 when the p-value is less than or equal to 0.05. Which is the alpha, the significance we're looking at. To calculate the t-data, right, we take the mean from the sample, we subtract the mean from the original hypothesis or population from the original. Then we take the standard deviation of the sample and we divide it by the square root of the number of people or things in that sample. So in this case, our t-value is negative 2.215. Okay, and we haven't had to find, that's the first time we had to find a number. Everything else came directly from the question. That's why I was highlighting those numbers. State the conclusion and the interpretation. So we do need to remember that our alpha was 0.05, right? So here is one other thing that we need to do. Let me get this set up for you guys, sorry. We need to use our t value in order to come up with the area. We need to figure out the area. So in order to find, oops, I still don't have my highlighter. Okay, we need the area, we need the proportion. What we have is the t-score or the t-data standard score, the same as the z-standard score, but not yet the area. So in order to do that, we could do it the same way we did using the calculator. Ooh, why don't I pull up the calculator so you guys can see me doing it too. And we could use equations for this too. This one just happens to be easier, I feel like, to remember. And we're trying to remember, you always have to keep your mind on the fact, you always have to be aware of what you're doing. We're trying to find the less than. So the number, the t-value we came up with is negative 2.215. So let me just clear out of here. Let me see, maybe can view the key press history. Right, so we are going to go to the distribution. And normally we have been using the normal CDF to find the area. Okay, but what we want to do is go down to, since we're using T, our TCDF. Okay. So our lower value, we're going from negative infinity to negative 0.215. Okay, remember this degree of freedom is the number of things in your sample minus 1, and I think we had 20, so this is going to be 19. Okay, oops. Oh, I must have used the minus sign instead of the negative, you guys. Sorry. Cool. So the area underneath one of the tails, and we only need to use one of the tails, is 0.01959. 0.01959. Oh, I forgot they already did this for you. Oh, so they even rounded it. Here I'm down at P down here. They even rounded it to 0.0196. And we are asking ourselves, is that less than or equal to our alpha? Okay, so is the area that we found using our t-score less than or equal to 0.05? True, which means, oh, somebody said something like a little saying, when your p-value is low, you must reject H of O. Okay, so there is enough evidence at significant level to show that the mean age of the onset and anorexia nervosa in young women has been decreasing. Okay, so we are rejecting that the fact that it was equal to 15, we are rejecting that, and we are saying that our alternative hypothesis that is younger than 15 is true. Okay. All right, what's next? I hope I'm still recording. Sweet. Okay. This one, the Pew Internet and American Life Project reported in 2010 the mean number of text messages sent and received. So this mean value, this is what I'm going to want to use our T in this case. Plus, we're going to use it the whole time because that's what we're learning. Number of text messages sent and received daily by teenagers is 50. So that's our original hypothesis, right? 50, our null hypothesis. Down here, let's switch up some colors. Let's say, suppose another research wants to dispute this and see if the mean is different from 50. So different from 50 means we're looking for it to be, and again, that should be H sub A, we're looking for that to be not equal to 50. So it's going to be a two-tailed test. This will make a difference when we find the area. When we use the calculator to find the area, we're going to have to multiply that by 2, okay? Because it's two-tailed. So state the rejection rule. We want to reject our hypothesis when the p-value is less than or equal to 0.10, because that's what it wanted us to use. We know that we sample a mean of 100. Oh, sorry. We have a sample of 100 teenagers with a mean of 47.75, which is less than the original mean of 50. So they're getting less texts. That doesn't seem right. I feel like that keeps going up. Well, maybe they're just talking about text. Maybe texting is going down and like other forms of social media are going up. So maybe you're not texting, you're like Snapchatting or chattering, snapping, whatever it is you kids are doing these days. Okay, so we're going to use these numbers that we found above in order to find our T number, which is like our Z number, which remember is our standard score. Then we need to, in the calculator, put that in to find the area or the proportion under the curve that we want to look at. So we're going back, and I'm going to make this smaller again. So I'm going to go back to the, I wonder if I could just change this. So we got negative 1.5, so I'm going to start from infinity, go to negative 1.5, comma, and then our degree of freedom is going to be 99. Okay, now here's the part we're interested in. The number I'm getting is 0.06839848081, but remember that's only one of the tails, and we're looking for two tails. We're looking for it just to be different. We don't care if it's greater than or less than or increasing or decreasing. So I'm going to multiply that number, that answer by 2. And so what I'm looking at is 0.13679, which is where they got this number here. So the question is 0.136 less than or equal to 0.10? False. So we are not rejecting. We are saying that, remember proportion, 13.6% of mean values will include that 47.5. Okay, and 13.6% is greater than 10% significance that we were looking at. So we're going to keep that hypothesis that teenagers send more than 50 text messages per day.